Very delighted to have our own Hongchan Choi, third-year PhD student here at CCRMA, to give this colloquium. So many of us have had the pleasure of collaborating with him, and he's now brought all of his audio processing skills to the web. I'm very excited. Thanks, Hongchan.
Thanks for the introduction, John. And yes, today I'm going to talk about one of my recent projects called WAAX. It stands for Web Audio API Extension. So in order to explain this whole project, I think I need to cover the basics, like what the Web Audio API is and how it works, and what's the, in general, like history of the web and audio. So, but before we dive into the main part of the presentation, I'd like to point out a few things that might be helpful for you to follow my story. And this is my homepage, so if you go there, it already has a link for the slides and GitHub project and the publication 9 paper, so it's already there. So if you want to follow the slides, this is the place to go, or you can even just type this URL over here. So this is about web technology. So everything works on the web browser. What I'm going to show you is pretty much you can just do it on your web browser. So I highly recommend to launch your web browser. But also, what we're going to see is a so-called bleeding edge thing. So this web audio API is not really settled. It's still under the active development. It's a drafting stage. So currently, the only web browser that fully supports web audio API is Chrome. So you might want to use Chrome to try out the code that you're going to see. But also the web audio API itself has been like almost 2 years, and I think personally it's a pretty stable, and I think it's great to work with. So let us start with the overview. So first, I'm going to talk about a brief history on web and audio in general, and we're going to have a look on the web audio API itself. Then I'm going to move on to my project WAAX library. Probably the next 2 sections will be the main event of the show, so we're going to see some live demo and web-based code editor, and also, I'm going to show some real web application so we can all play around right here in the classroom. Then I'm going to wrap up this talk by talking about the future plans and roadmaps for this project. So, history. I'm going to refresh the browser real quick. So 1990, we saw the first web browser in the world. The Tim Berners-Lee is the creator of the web browser called the World Wide Web. It is known as the world's first web browser. And he also created the file format called the HTML. So he's kind of a godfather of the internet. And 1993, the NCSA Mosaic was created, released, and to public for free. So it was a kind of a very big moment for the web industry. And at this moment, the Mosaic was supported a very basic sound playback. So I'm not sure about this software because I haven't seen that. So it's pretty old one, and it was really interesting to see it's really hard to find the deprecated software, the web-based web software in the internet. So, and 1995 was a very big step forward for the web browser. Netscape Navigator was released, and after that, in the same year, Netscape Navigator version 2 released with the support of JavaScript and the plugin architecture. So, actually, it opens the way to embed the multimedia, like audio and video on the web browser, but it still needs the plugins, like third-party plugins. And Apple and Netscape released the QuickTime plugin and Live Audio plugin, respectively, to support this the multimedia embedding system. And 1998, QuickTime 3 was released by Apple, and this was a really interesting moment as well because QuickTime Tree has support for the MIDI sound. So it has a built-in MIDI module, and it is based on the Roland Sound Canvas, which was extremely popular back then. And year 2000, we saw the Flash 5. Actually, Flash released a long while ago, but actually Flash changed the visual aspect of the web, right, like dramatically. But it didn't support the audio aspect, not much. But with the Flash 5, actually, the first notion of ActionScript came to the world, and a lot of people used those ActionScript to do some audio and musical stuff. So suddenly we were able to see all the like music jam stuff and music educational toy type of things on the web. And 2002, Apple released Safari browser, and they actually opened the source code of the web browser, and I think the name of the branch was WebKit. So now we're all using those WebKit browser like Chrome, Safari, and the other stuff. And the Phoenix was a web browser created by Mozilla, and it will became later the name of the Firebird, and then it becomes the Firefox later. So these two browsers got popularity back then. So 2004, Firefox version 1 was released, and actually it captured a substantial market share while still in beta. So it was a quite exciting ride for them. But suddenly, 2008, Google released Chrome, and it was very bad news for them. And also, 2008 was a very the meaningful year to the web developer because we had the first draft specification of HTML5 is something called next generation of web standard. So HTML5 has the web audio element. So this audio element, by using this audio element, people can play the audio file on the remote web server without any kind of third-party software. So it's a kind of big step forward. And 2011, the first draft of the specification of Web Audio API was released to the public. So this is a screenshot of the Google Doodle, which is created by Google team for the Robert Moog's 7th, 8th birthday. So actually, this is not like a pretty animated GIF. This is something that you can really play on the web browser. If you just Google this Doodle by the keyword of a Google Doodle Robert Moog, actually it will lead you to the archives of the Google Doodle that you can really play with. So let us talk about this Web Audio API. So what is it for? It's for the audio processing and sound synthesis on the web browser, as you might know. So I'm using the word modern here. So the modern means usually the browser that support the HTML5 spec. And technically, it is a high-level JavaScript API with a very small set of function methods, but it is with the native implementation. So if you make any kind of function call with the Web Audio API, it will run the code, audio code under the hood, and very fast and efficiently. So before this API, there had been some effort that trying to do like audio processing with JavaScript on the script level, but generally they're really slow. They're not really efficient. You will hear clicks and the audio drop out everywhere. So in terms of its development stage, it is still under the working draft, and the specification is controlled by W3C audio working group like Google, Apple, Mozilla, and Opera, and so on. So what it does is it gives you the basic tool set for audio related tasks. So generation, audio processing, and multi-channel support and spatialization and analysis. So you have oscillator and buffer source, sampler, and media stream. Media stream is kind of interesting because basically it enables you to stream the audio file that's on remote web server. Also, you can use a microphone for the web browser with this object. And for the processing, it has a bipod filter and delay, wave shaper, dynamics, and convolver. Convolver is sort of interesting as well. It does the convolution and very well. So if you just feed the impulse response file to this convolver object, it will do the convolution for you. And multi-channel support is has been recently added to the API. So audio listener is there. Panel has the HLTF function. So basically, this whole toolset is designed for the web-based game system. So HLTF is quite useful for that. And the channel merger and splitter for the multi-channel audio interface. So it is actually possible to hook up your 24-channel audio interface, and Chrome will immediately recognize the audio port. It's kind of amazing. And for the analysis and visualization, the web audio API provides very simplified version of FFT. So this is not for like the resynthesis or serious analysis. This is just for visualization purpose. Yes?
Can you get access to the microphone as an audio source?
Yes. Yeah, it's possible by using the media stream.
Media stream.
Yeah. But I will talk about it a bit later. Yeah. So I'm going to talk about some drawbacks. The web audio API has certain drawbacks that you might want to avoid. So let's talk about that. This is a browser, web browser, so it has some security issue there. So it has a limited access to the local resources, which means it doesn't have direct access to your local hard drive. If this is possible with the JavaScript, it could be a huge problem actually. So it is not possible to automate all the file accessing process with JavaScript. But you can do it with the drag and drop or by clicking input file button there. So user should be involved in somewhere. So you cannot automate the scripting process to access the file. And I think the same thing goes to the multimedia input devices like microphone, camera. If you try to access those elements, those hardware resources on your system from the browser, actually it will stop you. It will just display the notification bar and do you want to allow the access? So you have to give your permission to the system. But it's just one click away. If you just press allow button, then you can use all the resources you want. And this is also a huge problem. The inconsistent implementation between browser vendors. So Mozilla is making browsers, Google is making it, Apple is making it, and even Microsoft is making it. They're a big business, but all the company has a different size of resources. So their speed of development varies. So in terms of implementation of web audio API, the Chrome is the only browser that fully supports the API at the moment, and Safari has a very early implementation of an API, and Firefox it's quite interesting story there because Mozilla has their own audio API called Audio Data API, but it was quite long ago. But they decided to drop their implementation and they decided to adopt the Chrome team's implementation. And Opera also recently announced that they are going to drop the browser software base, and for their web rendering engine, they chose the WebKit. I mean the Blink, which is the rendering engine for Chrome. So there are also some technical constraints. That means you can do the JavaScript audio processing on script level if you can use the script processing node, but it's not really efficient. So you will hear a lot of dropout if you do that. So basically, we are kind of stuck with the basic tool set. It is possible to develop your own unit generator with the script node, but it is very limited in terms of its efficiency and performance. Also, JavaScript is for us computer musicians, the timing system the JavaScript provides is awful. It's like I think the precision of the timing system is more of like a millisecond level. So if you want to do something like sample accurate processing, it's not possible with the JavaScript timing system. But there's a workaround with the Web Audio API plugin system as well. So at this point, you might think, you might feeling like this. So why should I use this one? But let's look at the bright side. So this is whatever you write. Whatever you develop with this API is going to be a web page or website or like web something, right? So that means it's going to be ubiquitous. So if you write something, it will run like Mac OS X, like or Windows or Linux everywhere. Unfortunately, all I can see here is just OS X, so we can't test out the platform. But anyway, I'm going to strike this out because this is not true at the moment. Like I said, Chrome is the only browser to support this thing, so being ubiquitous is kind of not true so far. And this is a huge advantage for us, I mean the Karma community, because this is a web document, a web project. So if you make something, you can upload your own web server. Meaning that you have full control over your product. There is no app store or centralized regulation is involved here. So it is really great in the situation of if you're trying to like test out some idea, or if you're trying to like get a user feedback and do some rapid reiteration. This will help you actually. So no additional installation is required, and there's no big brother. You will have full control. And this is also a very big bonus. The people like me, I'm doing a lot of the UX stuff, and I really like the visualization system. So we don't have to deal with the OSC gluing application anymore. So rich visualization UI component can be handled by WebGL or Canvas, which is really good for 2D graphics and scalable vector graphics and HTML, CSS, pure DOM manipulation stuff. So you can build a really nice and fancy user interface. And the web browser is just a web thing. It's a network thing. So it's supposed to be work with network. So two APIs there, WebSocket and WebRTC. They are really, really great for this. And WebSocket is handles usually like a client-server model based on TCP. And WebRTC is kind of recently added to the spec. And WebRTC, RTC means real-time communication. The protocol, the API is designed for the audio-visual chatting. So we're doing a lot of stuff with that, like a Google Hangout or even Skype. So basically WebRTC is designed for peer-to-peer network based on UDP, but it's not really UDP. It uses their own protocol. But what I'm really interested in is WebRTC has a subset called Data Channel API. So basically you can send the raw arbitrary data to your peer, not like through the server. So it's quite good. So you're not saying you're not interested, right? So I kind of confident about that. I think that's enough of like talking, and why don't we just see some code example here. This is like obligatory tutorial for every language, so it's a hello sign. This is not hello world, but it's a hello sign. Mm-hmm. If you're using, if you're seeing my slide, if you type W key, actually it's shrink down a bit, so we can open up the console. So how do we open up the console? So if you're using Chrome, if you're using OS X, press Command Option J. That will give you the console. I already set my console to dock to the right side, so that might need some configuration, but I think this is good to go. So we can test this code right here on the slide. So basically what I'm going to do is just type that. C is new WebKit audio context. This will give you the audio context. So audio context is like your audio document or in MaxMSP or mini article chalk document, it will give you some kind of workspace so you can build your own scenes. So with this audio context, you can create a lot of interesting tools. I'm going to create oscillator and assign it to the O. That gives you the oscillator with the name of O. And we need to connect this oscillator to the output of this audio document. That's going to be destination. But we can't hear sound yet because the oscillator hasn't been started. So if I start the oscillator with the command of dot start parenthesis 0, 0 means you should play sample right now. Whoa, that's speed. I'm going to stop that. That's about it. That's really easy. Just 4 lines of code, you can have your sine oscillator. Okay. Next slide. So I'm gonna add one more control, one more node called gain node, so I can have control over the loudness of sound. But this time I'm not going to type everything. I'm just gonna drag everything and copy and paste to the console. Then you'll hear the sound. But here is the interesting part. This two line is actually controlling the parameter of your like very minimized synthesizer. It's kind of weird syntax because here's the oscillator instance, and the oscillator has a frequency, but this is not like the value that you can set directly. So this is a kind of a parameter, abstracted parameter. It's called the audio param. But if you want to access to the value of the frequency, you have to add this dot value. So why don't we just try that a couple of times? Frequency value, I'm gonna set it like 880, 440. I can see you guys having fun, so it's great. I think some people might notice that when we change the value here, actually you could hear was like a very smooth transition between frequency, not like an immediate jump between frequency, right? So if you change value through this method, actually you can avoid all the weird pops and clicks, which is acceptable to the common web developers. But for us, the computer musician, this is not an acceptable thing, right? We need to full control over everything. For that case, there are some other things you can do. I'm gonna refresh this thing one more time. I'm gonna show you here. It's a bit messy, I'm sorry, but so add here. So if you type a frequency and type dot, actually it gives you the whole set of the method that you can use here, right? And here's the thing, the set target. I'm sorry. That's
wow, how does he do that?
Yeah.
Wow.
It's amazing, isn't it?
5 lines of code.
Sorry. That means I need to pick up my son right now. But my wife is doing it today, so 880 right now. Oops. Set value at time. So this is a method that you can have full access to the frequency parameter. Now you don't hear the smooth transition, which is good. Ooh.
1x4.
Anyway, Yeah, it was a bit of coding, but this seems okay. But you're gonna see the worst case here. So if you're using the Web Audio API, pure Web Audio API, here. This is how you load a sample and play it just once. It's a 16 lines of code for that, so it's quite long actually. So it works but messy. So I think everything related to the loading or saving files is gonna be like very messy if you're using just pure JavaScript. So at this moment you will feel like this. What the? So that's where the WAAX comes in. So it is just to write less code and be more productive. So WAAX provides a very terse syntax compared to the pure JavaScript implementation. And it comes with a pre-built unit for synthesis and processing. I'm constantly updating my library, so it's going to have more. And it also gives you the basic tool set that you can like immediately visualize yourself, and some GUI component as well. And also, I'm trying to set up the structured timing management. Like I said, the JavaScript timing mechanism is really poor. So also, it comes with a web-based mini IDE called the WAAX IDE. So why don't we just have a look at this? Third syntax is just 2 lines. So for the oscillator, we can just do this. You can hear the sound. If you cut that out, just O cut. So you have control over the frequency and gain. I didn't put that in, but you can control over the type of the oscillator, like sawtooth or triangle, that kind of stuff. Sampler is much easier. So instead of 16 lines, if you just put these 3 lines, it will work. But for this purpose, I just copied 2 lines first, and the WAAX library is nicely reporting the kick sample is loaded, and then I'm gonna execute this node on thing. It's fun, but there's one thing you might need to know. Whatever this file still needs to be uploaded somewhere, because you don't have the web browser doesn't have a direct access to your local file system. So what I'm right now building is if you can just drag and drop your sample to your web browser window, and sample will automatically capture that and play it for you.
Is that kick on your server then?
Yeah, actually, this kick sample is included this slider.
Oh,
yeah.
Okay, so you're using built-in sound.
Yeah, that's a good question. And if you have to set up this audio graph with the pure like native implementation of Web Audio API, it's gonna be like long, really long. But setting up a sawtooth oscillator and low-pass filter, ADSL envelope with the convolution reverberation, it's just 4 lines of code, and you're going to connect them together in just 1 line to DAC. So I'm going to copy this thing. I just want to make sure that I'm just going to refresh once more and clear up the console. Copy this whole thing. Paste it. Okay. My impulse response is loaded, it says. I'm building an audio graph is here. And I'm going to trigger node with the envelope. I'm going to change the reverberation mix level to 0.1. Now you can hear the difference, right? So what kind of tool set it has? it has a, oh, I just skipped that. Oscillator, noise generator, which Web Audio API doesn't have, sampler and impulse train, and ADSL and the low pass filter, the ping-pong delay with feedback line, and convolution reverb and compressor. For the visualizer, it has a waveform spectrum custom visualizer. Actually, Jorge asked me to implement the waterfall, but I just didn't have time for that. It will be there soon. So for the visualization, it's pretty simple. It's 6 lines of code. I'm gonna just copy the whole thing and paste it over here so you can see the result in the slider, in the slide here. Now we have the one line. This is not animated, so I'm gonna call this B's draw function, and you can see the animated. So the thing is, this draw function will draw the waveform at the moment in the array. So basically, what you have to do is just loop that function in like every 70 milliseconds, then you will get very nice and smooth 60 frames per second waveform display. And you're gonna see that in the demo in a bit later. Okay. Oh, I just passed. Here. So I have some GUI stuff. This is also interesting. I'm gonna build the audio graph first. Clear. So you can hear that. And here's a horizontal slider. And it's just over here. Then you can make connection slider to the oscillator. And it's done. So we have visualization and GUI stuff, and here's a WAAX IDE. It's a web-based code editor for WAAX, and it has some demo application with it. So there has been issue this morning because the project page on GitHub was down. So I sent an email to the GitHub people, and their response, they fixed it, but I'm not sure. So we should see about that. So what you can do is just click this link, and it will open the editor. Yeah, I don't think it's working. Anyone?
For me.
Really?
It didn't move forward.
I think you are accessing to your cache. Yeah. So in that case, I prepared the fallback here. If you click the fallback, we will have the local version at CCRMA. So you already see the disastrous event. If you're using Web Audio, this kind of thing might happen. So this IDE is very simple code editor, but it has some nice thing in it. One of the nice stuff is if you change the parameter, you will hear the sound. You don't have to press enter or enter anything. That's a good part. And hello, type sawtooth. See? And basically, if you click the new button, by the way, here's a button if you want to, if you don't want to hear the sound anymore. This is like the remove shred button in BYOL. So it will just kill the audio injection in the background. So this is new button, basically give you the blank document. So here's a save button. If you save it, and it doesn't save you, it doesn't give you any file. It's just saved in the cache in the web browser. And that means if you access this web page like tomorrow or like 2 days after, you will have the working code there. And this importing give you this file dialog. This is what I was talking about. So web browser doesn't have direct access to the local file system, but there's a way to actually it is just giving the permission to web browser to access some file. So and export. if you press export button, it will give you some nice dialog, and you can type your file name. It will just save the file on your Chrome's download folder. Then you can import it back again. So here's the example button. So example button gives you some nice list of a demo, and I'm just going to briefly go through. And first one is Hello WAAX. Second is a THX demo. I just shamelessly just, oh, is this small? Okay. So I just copied all the Chuck code and just make a bit of modification to adapt to my WAAX library. I remember it's like 15 minutes of work, so it's quite good. I think Chuck, the syntax of Chuck and the syntax of JavaScript is very kind of similar. That has a very similar aspects, so it is easy to port the code to here. And here's some visualization. Basically, it is just a pattern sequencing with this array, so you can fiddle with it. And drum sampler. This is just a demo that can show that you can access the file to the web server. And here's a key: Z key, right shift, and slash. Here's a mixed level of reverberation. Now it's just 0.01, so I'm going to change to 0.8. It works quite good. And I think this is just a stupid input string. And here's an interesting one. The custom visualizer. So we have a waveform and spectrum, but with this custom visualizer, actually you can write your own visualization code. And this is done over here. So I just write up my own visualization and assign this function pointer to the custom visualizer, so you can just draw your stuff. So if you're doing like artistic or like more creative stuff, you can use this one as well. And GUI. We already saw the example, but this one is not working because this URL is wrong, because GitHub is down for me. So it has a waveform display. You can make some changes to your parameter and attack, decay, sort of things. So basically you can, this is your workflow. You just create a unit generator over here and make some GUI component and make some connection between the GUI component and your thing, and you can do some tweaking over here, not like by typing. So that's my idea, but I'm not sure how you feel. And I'm not going to talk about the last example. So that is WAAX IDE. So here are some thoughts. So web browser is running on the single thread architecture. This might be some problematic thing for us. So one of the reasons is all the JavaScript operation fight over the one thread. So if you're doing lots of graphic stuff, if you're doing lots of like DOM manipulation or like HTML, CSS stuff, or even networking, and all of those processes will fight over this one single thread. So if you're doing like heavy graphic stuff, you will hear some audio. You might be hearing some audio dropout if you schedule your musical event carefully. Those steps, and so this script process node is there. It's in the spec, and everyone is implementing it. But if you want to have really professional sound without any clicks or audio dropout, this is not your option. So like I said, JavaScript has a very poor timing mechanism. So scheduling event with accuracy is problematic. So we're not supposed to use the timing or timer from the JavaScript. we're supposed to use the clock provided by Web Audio API. That guarantees you the scheduled event a bit ahead of time, but it guarantees you sample accuracy. But thing is, this Web Audio API is a JavaScript API, so you have to make JavaScript function call to access the precise clock, right? That meaning you're kind of like a very in the dilemma situation. So here are some use cases and demo. So first one is, I think a lot of people brought the laptop. I'm feeling so great about it. And here's a link. The NB is an envelope power step generator. Basically, it's just experimenting with the idea of like audience participation and collaborative music making. But it's very simple because I built like 2 days ago. But Luke Dow and I had a lot of brainstorming about this project, so we are going to like push forward based on the current implementation. So if you click the link, you can just go there. So basic idea is you can just grab and move your envelope to create sound. So I think everyone should do it right now because I just want to try out the timing of this thing.
But if we don't get the time bar,
You don't get the time bar? Can you refresh that? Come on. So as you can hear, everyone is in sync, right? And if you press Alt key, actually you can control over the whole track.
Which key?
Alt option. So if you press the like hot button over here, you can see some instruction for your instrument if you really want to know about it. And another great thing is this share button because this is a web project. So if you just press that, here's a link and Control C, and if you close that out and paste the link to the web address, it will give you the pattern that you have made. So basically you can just send this link to other people that I just made this pattern. Also, I'm thinking of creating some Google using Google API. We can just collect all the patterns like socially, so we can just communicate with this pattern, like tweeting patterns. How awesome is that? That's one project, and the other one is for Chris. It's called Jukebox 228. This is going to be my last slide. So we have a 228 class, which is basically introductory computer music class at CCRMA, and we all do the homework, like 5 or 6. And the class is usually really huge, like 30 or 40 students. So I just created a web crawler with JavaScript, and basically this crawler is just go through the 10 years of homework factory and just collecting all the URL for wave files. So right now I have 2 years of data, which like 900 wave files. So here's the result. There's 902 homework, and here's the 3 audio stream. So randomly choose the homework from the 900 wave files. Right now it's very sound funny, but sometimes the mixture of the 3 sounds could be good. So it's really interesting to see.
I remember that one.
So one of my ideas is just we can play this sound like at the Karma lobby, like forever.
It's kind of like a force field.
Yeah. So I'm gonna just stop it over here. Where is it? So right now it's a fifth revision, the library and the IDE. So I'm looking for the 10th revision. I really want to have this type of feature. So live coding in WAAX IDE. By terms of live coding means I mean like the Brad Victor's idea. So slider knobs just right in the editor, not like separate interface. So you can just control the numbers and parameter without typing, without even typing. So the next thing I want to achieve is the framework for the timing and modulation. For the timing, I think I worked it out something, but for the modulation, it is quite serious. I think that it needs a very serious discussion. So I'm collaborating with many people about this one. Also, this is also exciting news for the web audio scene because 2013, I think this might be revealed at the Google I/O, maybe. But the WebMIDI API will be released soon. I was told like it will be released in 2 weeks. First implementation in Chrome. So that means we can.
Is that upstream or is that in like the regular consumer browser?
What do you mean by that? Oh yeah, that's a good question. I think Canary first. We should go Canary first. Yeah. That means if we can plug in the USB MIDI keyboard, and Chrome will recognize it, and you can directly connect your web audio scenes to your web MIDI component, so you can just play with it. And also, I already discussed this thing. I already talked about this thing. So WebRTC has a data channel API. It's already there. It's in the browser, so you can send any arbitrary data, including audio. So if you just use the WebRTC as the default feature of transmitting audio and video, it's going to be compressed somehow. But if you can use this data channel API for the raw audio or the control data like OSC, then it's going to be much easier to work with. Because using OSC on the web browser is not really possible without any additional component. So, and actually Miles talked about this thing. So there are some subset of JavaScript called ASM.js, which is designed for high performance JavaScripting, and maybe it could be another direction as well. But I heard some negative thing about this, so we can talk about it together. Yeah. So that's all for now. So I think I'm open to the discussion. Any question or comments? Yes.
Hi, my name is Tom. Thank you for your talk.
Mm-hmm.
My question is, did you start the project trying to solve a problem or address a user experience that you were interested in?
That's a really good question, but at first I approached it to this topic as my just research. It's just pure research, because the developing a JavaScript library is more for developer, not for like end users. But I suddenly realized that if we can have more like components that might enhance the user experience, I think it might be helpful for the end user as well. So,
how did you know when you were done?
wow, that's a really good one. I don't know. I have no idea.
That's good.
Yeah.
Art's never finished.
Yeah.
Thank you.
What's the status for mobile devices? Like
That's a really good question as well. Chrome team is working on it. Chrome has a dedicated Android engineer. I'm not sure. I don't think I'm allowed to say this, but are we still streaming?
Yes, we are.
Okay.
Is that okay? We'll try to stop streaming.
We can talk about that later.
I can mute.
It will have. It will have soon. It will have soon. Yes.
Hongchan, this is just to remind you of a discussion you and I had, which may address your
Oh, yeah.
question, which
Please
was
have
that there are a lot of sort of audio people like myself who don't really know how to write web stuff, and so this is partly serves to help someone like me get into web interactions.
Yeah, I forgot to talk about that. Yes.
Yeah.
Well, it's also just, I mean, it's just great in general because, you know, I have been doing a lot more web stuff lately, but I would rather not, and this is going to save me a lot of time. You know, and it's just kind of like a lot of these other things, like, yeah, you can do graphics in Canvas, but then there's the Raphael library, there's the Kinetic library, there's all these really great frameworks. There's jQuery, they're built around, you know, all of these other things, and they're just, so many of them, you know, cross over and duplicate each other, but who can?
I'd like to say something about that because my visualizer is not intended to like fancy thing like Raphael.js or that kind of thing, but you can hook up the custom visualizer to Raphael.js actually.
Oh,
yeah,
cool.
You can do that.
Yeah, well, no, I'm just sort of saying it's just, you know, it's just nice to have these frameworks, and you know, they make, you know, when you're an independent developer or an overstretched developer, it's, you know, fantastic. I've been doing a lot of stuff with not WebMidi, but the sort of precursor with the JazzMidi plugin. And so I've actually developed, I work with controllers, and I wrote with Livid, and we make lots of controllers, and so I've made an editor for all of our controllers that just works in the browser, and it's just, it's, you know, it's great from just sort of a support standpoint, because someone says, oh, I have this problem, and it's like, oh, that problem is 2 lines of code, I upload it, and then it's solved for everybody at once. You know, I don't have to say, oh, you're on the wrong version, you know. So this stuff is just, I'm all in.
Thank you so much.
I look forward to using this. This is great.
Yes.
I have a question from Colin Solomon in the web chat. Hongchan, can you talk more about your ideas or conversations you've had about the timing syntax?
Oh, yeah. Because I discussed that topic with the colleagues. Yeah, that's why he asked the question. Okay. Oh, before I open that link, I think I should go back to over here. Sorry.
Oh, yes.
So I just put the link here. It's a HTML5rocks.com document, and the article written by Chris Wilson. He's the developer advocate at Google, and he works with the Web Audio API team, and he's really good at this. And so he actually wrote a lengthy article on how to manage the precise timing mechanism with the JavaScript. So he has all the research here. So basically, this is what you want to get, like very precise timing for a musical event. But this is what you have with the JavaScript timing. So they're kind of very jittery, you can see. So what you have to do is using this based on this JavaScript timing function, but you're gonna have to look ahead of time if there is an event that you want to play in very precise time. So if there's any event in that look in between the look ahead time, you just grab that event and schedule it with the Web Audio API schedule function. Then your event will be guaranteed in play a very precise timing. Yeah, that's the idea. Yes.
How did you debug your development?
I usually use the Chrome Web Console. Yeah. My work system, my working environment is a Sublime Text 2, and Chrome Dev Console, and Terminal. Yes.
I just wanted to reflect that it's getting quite noisy in the chat room, but there's somebody here who says they're working on a Faust web audio compiler right now, and there's some discussion about whether Faust would be a nice thing to have.
I don't think I'm not allowed to say that, but the idea is the Faust team already has their branch of WebKit. I'm sorry. So their version of they have their own version of WebKit which has a Faust support. So in that version of WebKit, you can actually write the Faust code and load it into Web Audio API, the custom node, and do some fancy DSP stuff. But it's not like a standard released version. So you're not going to see that in Chrome, actually, or Firefox. But that's a good question, yes.
Speaking to that, like I'm doing research right now on working on a compiler to go from Faust to a JavaScript node. That's where the ASM research is coming in. We don't have anything working yet, but they do have currently like a web audio compiler that does a few things. Like Carpal Strong, I think works really well, but Noise doesn't. So that's kind of like where it's at without relying on.
Yeah, if you're doing really simple stuff like Carpal Strong with the JavaScript process node, I think it will work. Basically, my input train is also based on the JavaScript node and some program-dependent compressor node. I wrote the JavaScript code for that for my library. But if you're like moving your screen with the mouse fast, you will hear the audio drop out because the browser gets really busy with redrawing all the screens, and you will miss the audio samples from time to time.
But that's potentially just like a deeper problem with the fact that everything's on a single thread in general.
Yeah.
Which kind of is a bigger question of like how things are being dealt with.
Right. Yes.
So this reminds me now that looking at this, this is a solution that I've seen years, like 400 years ago. It was in MIDI Lisp, which was also constrained in terms of the kind of find the accessible clock that you could get. So you would schedule ahead. If you're going real time, you could insert.
That's
things would be guaranteed. MIDI Lisp had garbage collection problems. Is there anything similar here?
Web browser, the JavaScript engine is always suffers from garbage collection, actually.
So
it's the same problem.
Same problem. Yeah. So is there a solution to that? Because that really hurts.
I'm not sure about that.
Huh.
Yeah, I'm not really expert on that matter. So.
Yeah. So ultimately, what you had to do was guarantee no cons, like no garbage creation. And cons-free Lisp is tricky.
I think that's really interesting perspective, because recently I realized that all of the problem that I'm having is just a problem that we had like 10 years ago. Because if we like moving on to the web world, we have to build everything on top of web browser. It's getting slower. You're losing performance because you build like Castle on the browser. But basically, it's just running your program on the slow computer. So we are having like similar issue with back then.
The issue of the JavaScript processing node, that being the only way to sort of customize and extend it with your own DSP.
Yeah.
Do you know why it is that, or why they didn't use? Why isn't there perhaps a more robust solution than that? Or is that not really possible because you're working in a browser?
Yeah, I'm pretty sure the developers are working on making this JavaScript node more efficient, but I am not so sure about having another custom DSP node. But I think I saw a very interesting discussion is going on the W3C mailing list. They are trying to come up with a DSP API for web browser. That might be the solution, but it's not even drafted yet.
Right.
So it's just everyone is just
talking
talking about.
There is thinking about a sort of plug-in type of compiled plug-in possibility type of thing, like the way the VSTs are used.
Then it will defeat purpose, I guess. So the reason why we're using Web Audio API is just not using additional software. So
yeah.
Yes.
How do you feel about the unit generators and processing primitives that are already there? Because if you have everything you need running native, and you can just knit them together, then life is good. But if you need some low-level extension, and you don't have something like a Faust, facility for making new native modules, then you're really kind of stuck. You can't really.
Yes, that's what I'm feeling right now. But I also feel like the quality of Oscillator and the compressor and convolution bytecode filter that Audio Web API provides is quite good. Actually, they spend a lot of time to optimize and to get highest quality possible. So I can't discuss the implementation itself, but the source code is open open in the web. So if you want to really know about it, you can just go in there to look at the source code. But as far as I'm concerned, the quality of the primitive audio nodes are really good. Yeah. But like you said, in terms of extending the vocabulary, we are kind of limited. Yeah.
What language is it written?
C++, I guess. It's WebKit and Blink. Yeah.
Do you know if there's a plan to include control over the sample rate? Right now, I think it's fixed and there's nothing you can do about it.
What was your question?
The sampling rate, the audio sampling rate is fixed right now, I think. By the web audio API, there's no control over that. Do you know?
Oh, sample rate?
Yeah, sample rate.
I don't think so. Yeah, I think we are free from that.
Sorry?
We are free from that problem.
Free from the problem in the sense that we cannot change it. That is fixed.
I mean,
It depends on your audio.
yeah, it depends on your system clock, I guess.
Yeah, the browser probably decides.
Yeah.
And
It's just
system-
automatically detect the sample rate that you're running.
So lookup thing.
Yeah. It'd be nice if you can make it run like a lower sample rate, for instance, so you can free some processing power.
Right. That's not possible. Also, I haven't discussed in the slide or talk, there's a audio context called offline audio context. So everything I explained so far is just about being real time. But if you're using this offline audio context, you can do some other things without dropout possibly. Yeah.
So you can render things.
Yeah, render things. Yes.
Yeah.
So if you like load the big wave file and try to draw the waveform of that, and usually what you do is just use the offline context and get the old data, the image first, then move on to the next step. Yeah.
Can you also render the visualization offline? The audio?
That's possible because we have SVG. So if you can connect the custom visualization node to SVG object, SVG element is just basically PDF. So if you draw really serious and nice fancy vector graphics, then you can just export to the graphic document. Yes.
And that would be an animated graphic document?
I think it depends. If you want to really serious about being animated, you can use the Canvas 2D. But in that case, how would you get the final file?
That's what I'm wondering. That's what I was asking, if that was possible.
I think SVG is more like static document.
Yeah,
Not like static, but it's more like the high precision quality drawings. And the Canvas is more like a robust and fast animation.
Yeah.
Any other questions?
I'm gonna stay around a bit, so if you have any question, yeah.
Yeah,
Or
great.
if you have any feedback, yeah, please.
Very impressive.
All right, thank you so much.